only one processor operates on the CPU. So that means I told you, like when you run a program, there are multiple processors. But when you take a one processor, single processor, one time it will run only one process at a time. So let's say you have four processors. We have seen process one, process two, process three, process four, one process at a time. So what will happen is you have given very short time interval for one processor. Then after that, you will give another time for the second processor, third processor, and so on. So there'll be an order among them, right? So everything we need the share. So we have to, share the resources, right? So let's move on to the memory management. Can you take down the memory management, and then let's move on to memory management video. Earlier, when you have multiple tasks or multiple processors, you can see processors as well. So you have to allocate the memory, right? But the problem is we have a limited memory uh, in our machines, like 2 GB or 4 GB. So which means sometimes you can't load the entire program if it is not very small enough. So because of that, um, you know, you have to, load part by part, and then different processors differently. So without any, problem. So sometimes you have to save data for multiple processors. And then whenever you finish the task, you have to empty the space as well. Right. Then let's move on to device management. So under device management, let's talk about how it varies, right? So let's move to device management. Let's take down, then I will explain.
So far, we've learned how hard our kernel works by handling files, managing file storage, juggling all the different processes running on our computer, and allocating memory. Another important task that our kernel handles is managing input and output. We refer to devices that perform input and output as I/O devices. These include our monitors, keyboards, mice, hard disk drives, speakers, Bluetooth headsets, webcams, and network adapters. These I/O devices are all managed by our kernel. The kernel needs to be able to load up drivers that are used so that we can recognize and speak to these different types of hardware. When the kernel is able to start up the drivers to communicate with hardware, it also manages the transfer of data in and out of the devices. I/O doesn't just mean the transfer of data between us and our devices. The devices also need to be able to talk to each other. Our kernel handles all the intercommunication between devices. It also figures out what the most efficient method of transfer is, and it tries its best to make sure our data doesn't have errors during process. When you're troubleshooting or solving a problem with a slow machine, it's usually some sort of hardware resource deficiency. If you don't have enough RAM, you can't load up as many processes. If you don't have enough CPU, you can't execute programs fast enough. If you have too much input coming into the device or too much output going somewhere, you'll also block other data from being sent or received. It's slow is one of the most common problems you'll solve in an IT support role. Knowing the potential sources of that slowness is a big help when you're trying to narrow down the cause of the latency.
So under file management tasks, we have create and delete files and directories, provide access to files, allocate space for files, keep backup, and also secure files. So under this, we can say an information could be stored as files in storage device such as hard disk, operating systems. Means protecting the system. So when you talk about protecting the system, we have to protect the system from unauthorized users. That means sometimes people can come into your machine and access it. So for that, we use what we call user authentication. Authentication means you are providing username and password. So without username and password, you can't, you know, uh, log into the system. So authors, users cannot access the system without their username and password. So this is called authentication. And then you can use file read write operations. Sometimes we'll restrict read and write for some of the users. Some can read the file but not write the file. So likewise, we can work on different file attributes to restrict access. Then encryption. What do you mean by encryption? So when you send the data, you jumble the message so that nobody can read when you transmit data from one point to another, right? This is called encryption, right? That means nobody can read this in a way when you're sending the data. Only authorized persons can read the data. So we call encryption. And even backup, when the system fails, we have to have a way of getting back into the working condition. Now for that, we can keep back up the data. And then firewalls. I think we have already discussed this earlier as well, especially in a network environment, especially when you have internet connection, people come into the system. Then you can restrict those who are trying to come in the system using the software tools we call firewalls, right? So this is called security management, so that you know operating systems make sure that the system in a secure place. And the last one, what we call is the interface, providing interface, we call it last one. We can say providing interface. Let me write that. So in this particular case, we are going to look at the next one, that is providing interface. Let's start with the video.
Okay, we've covered the kernel's major responsibilities. Now, let's discuss the final major aspect of an operating system: how humans interact with it. This is what we call the user space. When we interact with an operating system, we want to do certain functions like create files and folders, open applications, delete items. You get the idea. There are two ways that we can interact with our OS: with a shell or a graphical user interface. There are also some shells that use graphical user interfaces, but will work with a command line interface or CLI shell for the most part. This just means that we'll use text commands. A graphical user interface, or GUI, is a visual way to interact with the computer. We use our mouse to click and drag, to open folders, etc. We can see everything we do with it. You probably use a GUI every day without realizing you're using one. To watch this video, you probably used a GUI, clicking icons and navigating menus to open your web browser and navigate to the Coursera website. People usually recognize a device or product based on its GUI. You might be able to spot the difference between a computer running Microsoft Windows or Mac OS based on the design of the windows, menus, and icons. You've probably seen GUIs in other places too, like mobile phones and tablets, ATM machines, and airport kiosks. A shell is basically a program that interprets text commands and sends them to the OS to execute. Before we had fancy visual interfaces, commands like create a file had to be typed out. While we have GUIs today, the shell is still commonly used to run commands, especially by power users. Power users are above average computer users. In Linux especially, it's essential that you actually know commands, not just a GUI. This is because most of the Linux machines you interact with in IT support will be accessed remotely. Most of the time, you won't be given a GUI. There are lots of different types of shells. Some have different features, some handle performance differently. It's the same concept behind different operating systems. For our purposes, we'll just be using the most common shell, Bash or Born Again shell in Linux. There's also a shell for Windows called PowerShell, but we won't be covering it here. You'll learn more about Windows PowerShell in the third course of this program, Operating Systems and You, Becoming a Power User. Throughout this program, we'll learn how to use the Windows GUI and Windows Shell PowerShell. You might be thinking, but it's easier for me to navigate a GUI than it is to use commands to do the same thing. So why would I want to learn both? I can't stress this enough. It's vital for you to know how to use a shell in an IT support role. Some tasks can only be completed through commands. In more advanced IT roles, you might have to manage thousands of machines. You don't want to have to click a button or drag a window on every machine when you can just run a command once. You're actually going to learn how to automate this in a later course. Using a GUI and shell isn't all you'll be doing. We'll also interact with our operating system through applications. There are system applications and libraries that we use on a day-to-day basis, like the login application, system settings, and more. Throughout this course, you'll learn more about how to use system applications. And we'll even get hands-on with the applications used in your operating system.
Okay, so what are the things you have seen in the video? You can click on this one, so you will get a window like this to open the files. So you can go to the document, and then you will see this is in Google Drive, and then inside the Pahana directory. So these are the set of files within the Pahana directory. So this is using graphical user interface, isn't it? So the same way you can use command line interface as well. Maybe you have seen in the video as well. You can go to the same place by typing type commands, like you can say cd Google Drive and cd Pahana. Now you are within Pahana, you can say the command, and then this command actually shows you the file. So this is how it will look like in a command window. So let me put an half and half in the screen. So I will put half and half. This is the same thing. Now let's say I want to get all the files start with capital O. So that might be a bit difficult sometimes. You can say capital O, and then you can put star to get it, right? And then star again. So we will get all the files starts with O, whereas in command line, this is very easy. Maybe we can say, okay, dir capital O star dot star will give you all the files. This is much clearer than working the graphical user interface. So it's more easier when it comes to a command line interface, right? So as you can see, so it depends on what the purpose you use. So in some cases, we prefer graphical user interfaces. You have icons, you have different graphical controls are there, so you learn. Whereas in command line interface, you have different commands to use. So, and then we'll share the screen. So we'll start with providing interface. Yes, can you type up to this point? So when you talk about the interfaces, we discussed there are two types of interfaces provided by the operating systems mainly. That is command line interfaces where users has to type the commands. So they have to remember the commands. And this is early days in old operating systems like MS-DOS. The main interface was the command line interface. But even nowadays, we can find this interface, especially for power users, that means more advanced users of the system. Like it is called shell. And then, for example, PowerShell in Windows or Bash shell in Linux could be examples for CLIs. And then the next one is called graphical user interface. In graphical user interface, use uh, uh, use pointer and then other graphical elements like windows, icons, and menus. In simply, we say WIMP. And then you can use this graphical element for the commands and you don't have to remember the commands. So I told you about the windows. Usually we will see as a rectangular shape. Now, for example, this is Word document. It's in the rectangle window and this is called a window. And then small graphical elements in the screen, we usually say the icons. And then you have different menus, right? So menu provide different information. File menu, for example, uh, provide different information for different tasks. So this is possible with graphical user interfaces.
Hi, Sandesh.
Okay, so next we'll move on to the classification of operating systems. We actually briefly look at those early as well, but let's talk about in detail again. Um, but this is simply we discuss what we exactly have, right? It's evolution, so how things have actually changed. Now, next one we can talk about the classification. So let's write down the classification of operating system. So this is the next topic that we are going to discuss, and operating systems.
Understood.
Right. When you talk about classification, there are many ways to classify this, right? Now, in this particular case, we are going to look at single user system. That means only one user can access the operating system. And then single task, one task can be executed. right? Um, and then single user, we can have multitask. That means one user can work on multiple tasks. Then multi-user multitask. That means you can have multiple users and multiple tasks, right? And then we will have real time, and then which we call sometimes time sharing. And then we can have finally uh, uh, the distributed. So there are different types of you know systems available. So we have real time, we have time sharing, and then we have distributed systems, right? So these are the some examples of classification of operating system. For first of all, let's write down the classification, and then we will talk about them separately, right? So we can see single user, single task, then single user, the task, and then we have multi-use, multi, and then multi-threading. We have multi-threading, and then we have real time, and then time sharing, and finally distributed. So let's start with the single user, single task operating systems.
hari sir.
Right. So let's write down the details. First one, as I told you, single user, single task operating system. So we will have only one user, and then one user can access only one task, right? So that's what we call the single user, single task. So let's write down. Um, OS facilitate single user use system for a particular task at a given time. So it will give only a one task at a time. Right. Then let's take down single user multitask. So in that particular case, a single user to use the system for multiple tasks at a given time. I forgot to give some examples. We will say, okay, MS-DOS as an example.
Hardest.
So we can say multitask, we can say all the Windows operating systems and Linux operating systems. We can take them as examples for this single user multitask. Right. Then we have multiple users, multi user multitask operating systems. Multi-user multitask operating systems. So this operating system, multiple users to use the system for multiple tasks. So examples are Windows Server machines and also Linux. It's provide everything. Then we have multi-threading.
Hi.
Okay, so multi-threading is a slightly different version of the operating systems. So they are we call multi-threads. We call it. Um, so um, we can say when it comes to multi-threading, so you can run uh, several segments of computer program called threading. Um, so another task can be stored with the program, and you can access complex data, not like early case, and maximally you can use the processor, right? So in a way that provide uh, way to improve the performance. What happens there is it will parallelly execute the sub processes. So earlier, although there are multiple tasks, so here actually multiple parts of the programming is executed. So many operating systems in computers nowadays, they use this multi-threading operating system, right? So there we will use multi-threading operating system, right? So you can say a thread is also called a lightweight process. So it's actually, you can say sub process, right? It's not a very complex one. It's a lightweight process. Yes. So these threads provide a way to improve application through parallelism. Most of the operating system use today use multi-threading. So I'm not going to give you any example as such, but all the operating system nowadays, it uses multi-threading. Then the next one is real time. So we can use real time operating system. So uh, the time requirement of real time OS is very small, which means time taken by the system to respond to an input and display the output is very small. The time requirement of real time OS is very small, which means time taken by the system. So that means when you provide the input, as soon as you provide the input, you get the output in real time operating system. Examples: medical imaging systems, robots, air traffic controllers, even in the printers, scanners.
Haris.
So these are the example for real time. So at the same time, even ATM machines like ATM. So what they have is called real time OS. Very dedicated operating systems are there, right? And the finally, no, not finally, we have time sharing systems. We have time sharing operating systems. So time sharing means many users use the same system. So you are using a particular system at the same time, right? So the idea there is, processor time you are going to share. That means, multiple users access a system at the same time. And what happens is processor time is shared among the multiple users, right? This operating system facilitate multiple users to access a system, to use the system in a time sharing basis. Here, the processor's time is shared among multiple users. So there's no particular operating system I can name for this, but even then, some operating system actually uses this, right? So this enables time sharing system means normally this seems to work on single computer. So you work on a single computer there and it's called time sharing, right? Finally, we have distributed. So distributed. So this is what we have nowadays. If you take, for example, uh, Gmail or Google, right? This is what we have. It's called distributed operating systems. Right. So there what have you have multiple processors, right? Multiple systems, and then you will serve for multiple users. So this OS facilitate multiple users to use multiple systems, various hardware and software applications throughout a network, but user feels that it's a single access point, or is facilitate multiple users to use multiple systems. Multiple systems. The the processing processing distributed among multiple processors. When you ask perform a particular task, it's not only limited to one machine, but it will distributed. It will share among several machines, right? Okay. So with that one, we actually discuss the classification. So with that one, we will finish for today. Putih api danata, meterin natara karamu. So what we have discussed today is uh, again we continue the operations of functions of operating system. We discuss what is file management, security management, and also providing interface. And the interface we discussed, there are two types of interfaces, CLI and graphical user interfaces. Then we also discuss different types of classification of operating systems. as single user, single task, single user multitask, multi-user multitask, and multi-threading, real-time, time sharing, and distributed, right? So next week we'll talk more on the files and directories, different file types, and then folder management, and then the file security, privileges. So that is actually file storage management. So basically file handling in detail we will discuss in the next lesson. Hari putehna apita ada terteri natara karam.
Hi, sir.